Hi everyone, welcome. Good to see you all. With no further delay, the topic today is how to design user authentication. Before you go too much into it, it starts real simple. Imagine it's 1998 and you want to introduce logins to your service. So people can have an account with your service with email and password. You want to confirm the email and you only want to let logged in people in. Well, you only want to let people who have registered in and they have a login session. We're going to start by discussing how should the application be structured, which database would you use, which database schema would you need, and what are the bottlenecks here. Any takers who want to go first? I have a random numbers generator.
I want to clarify some requirements. So is 1998, is it a must that we should use only technologies available in 1998? Or do we pretend that we are living nowadays, but just login is not implemented?
Well, good question. The reason I mentioned 1998 is that I want us to mentally be in the world where there are no auth services such as Google. So if you want to answer by, oh, I'm going to allow login by Google or login with Google, let's not do that just yet. Ideally, we come all the way to design that.
Okay.
Yeah, because I guess my first piece of advice usually would be just don't do it. just log in with Google or something else. And, leave the problem domain to people who've already done it.
Well, this meetup grew from me hosting practice sessions for system design interviews. So my piece of advice here is, if in doubt what to say, imagine you're being interviewed and you want to get a job at Google. What would you say to impress the interviewer? Since I'm not saying it's the goal we should all pursue, but I think it's a reasonable target to aim at.
Well, okay, then like the next step down from just log in with Google is using cloud hosted authentication models like serverless auth from AWS, which kind of does all the hard parts for you.
What exactly does it do?
Well, it lets you create sessions, and it deals with session persistence and caching, and essentially all of the performance penalties. And I'm not an expert here. I just read about this recently. But you'll still have to deal with the data model for your users and so forth and their credentials. But so far as actually validating sessions and allowing certain services or certain endpoints to be authenticated only and to be behind an authentication kind of barrier and be accessible to authenticated users, it kind of takes care of all that for you.
Let's talk about the user data model first.
Okay.
What do you need to store about the user? The simplest task so far, you just need to make sure they can log in, assuming they type in the right password.
Well, clearly you need some representation of their credentials, their email and their password.
Okay, can you store the email in plain text?
You shouldn't do that, no.
Even email? Not
even email.
Interesting. So I hope everyone here agrees you should never ever store passwords as plain text. If you don't store email as plain text, then how do you reach out to users?
Quick question. Are we living in the post-GDPR world or pre-GDPR world?
Pre.
Well, whether the regulation exists or not, its raison d'etre is still there. The reason for it, privacy, and if you don't need a mailing list, then you shouldn't store a user's email. If you do need a mailing list, then you should probably deal with that separately.
Okay, let's table this for now. Let's implement the basic functionality. I'm the new user. I would like to create an account. I type in my email, I create the password, it fits some basic password strength requirement. I'll probably type it twice so that I don't mistype it. And I need to confirm my email. And after that, I can authenticate. Let's walk through these steps. In my random number generator, Julia was first. And you're muted.
So let's see what we have so far. We have user, and for user we need email and password. And are you interested in how is it happening? How are we working through these steps? How is it happening? Am I correct?
Well, yeah, let's start from what do we need to store in a database?
Okay, so basically for user, we need two things, email and password. As for email, if we don't save it as a plain text, then we should encrypt it somehow. But I'm not. But I'm personally not sure why we need to do this for email.
Victor, do you mind if we start with unencrypted emails first? Just to keep things simple. So let's say the emails are not encrypted.
Okay, then but definitely we need to like encrypt password, because password I totally agree that it should be encrypted. Yeah, and so and how would we store it? So if then we have password from user, and we need some hashing algorithm which will encrypt it, and in our database we will save this hash, this encrypted email.
Okay, first things first. You first said encrypted, and then we went to hashed. These are not the same.
Okay, so that's how to say. And should I choose here, like I need to encrypt it or do hash?
Well, yes, but before we choose, we need to be able to tell the difference. Who can articulate in one sentence what's the difference? Dima?
Yeah, so basically hashing is one way, converting password to something that you can't unhash, and encrypting usually means some symmetric or asymmetric way to actually get back your original value.
Right. So do we actually need to decrypt the password, or we only need to confirm it matches the previously typed in one?
So I think we need to encrypt it, because no one should know your password, and it should be saved in a database in an encrypted way.
So if it's encrypted, it is possible to decrypt it. But we never ever want to decrypt it. Let's put it this way. If bad guys just steal your server physically, have access to every single bit that was in a database, you want the users to be safe. You just want to reset all their passwords. You want to send a big apology email. Hey guys, sorry we got this security issue. Please all reset your passwords. The old passwords no longer work. And that should be it. You should not have to worry about these people's passwords being leaked, right? As Victor said, you probably also want to make sure the emails are not leaked, but that's a different conversation.
Yeah.
The idea is that if you encrypt them, it is possible, maybe even in theory, to decrypt them. But you never ever need to decrypt them. The only operation you perform is matching the password the user has just typed with your database contents. You never need to decrypt both. in order to.
Yeah, that's true. That's true. That.
So we're talking hashing here. Maybe from the top of your head, do you know any good hashing algorithms?
MD5. MD5.
MD5. Anything else? I mean, it doesn't qualify for good, but if we're in 1998, it's kind of okay.
So what else? I'm trying to.
Let's do a small. Let's do a small detour. Anyone want to chime in on hashing algorithms?
Yeah, let me step in. So essentially, I think we will use some SHA-2 or SHA-3, and we will use salt in the beginning in order to avoid rainbow tables. I agree with Victor's idea that we should not reinvent the wheel and basically need to take some authentication password handling scheme from ISO standards or like some others, but we're kind of talking about the whole thing. And what I remember last is kind of Unix authentication, that we take a hash function and some salt at the beginning, and then we have a hashing representation of the password.
Okay, well, that's all good, and I think it's 100% correct. Let's take it step by step. You used the word salt a couple times. I'm not sure everyone.
Yeah, it's some random piece of bytes in the beginning. What I don't know is whether it's unique for server or unique for the unique for servers, or it's like changes for each other user in some scheme. But let's say there is just some in the beginning, there is some piece of random bytes, and what I know is that it's used for impeding like brute force hashing with some predetermined values.
Okay, let's still decompress this, Dima.
So I'd say the idea behind salting is to prevent collisions. So if two users choose the identical passwords, it will prevent, like, it will still make the hashes, resulting hashes, different for different users. So that was an idea.
Yeah. Okay.
So the original thing about salting was to prevent the usage of rainbow tables.
We should really describe to everyone here and in the future what salting is about.
Yeah, so basically each time you take, so let's imagine you are using MD5, and the traditional 1998 way of dealing with a password was to take an MD5 of your password and just storing it in a database. And the way hackers dealt with this was that they...
Let me stop you here as well.
Yeah.
Since you're talking, let's take another half a step back.
Sure.
You are the databases guy. What should the database schema look like? What would be the schema of the table row that corresponds to the user, with the key being, let's say, email for now?
So the key would be the email, and that would be a plain text email. There was going to be some password field, which would be a binary or a text storage for the output of your hashing algorithm.
And why would this not be enough? You started describing this. Let's just make sure it's covered.
Sorry, what's...
So you have the email, let's say it's plain text, and you have hash password.
Right.
These two would not be enough because, as Dima said, collisions are an issue, and as you said, rainbow tables are an issue.
Yeah, so you can solve, there are different ideas of how to implement salt. So you can have a per user salt injected into the hash. Or you can have a per server salt injected into, per service salt injected into the table, depending on what are you trying to protect yourself from.
Okay, we should really describe what is salt used for.
Salt is used to prevent the hacker to be able to create all the values of hash functions, an inverse mapping of hash function into the source data. So basically, this adds a random more input that's required for this algorithm that would make impossible to store the whole inverse table of a hash function.
So two things can go wrong if we do not use salt. One thing is that, let's say you have this mapping between from user email to the MD5 or whatever other hash of the password. The first issue you would have is that the attacker can just take a dictionary of commonly used passwords and hash them all. We should also mention that hashing should be a slow function, so that it should be really hard to try like 1 billion hashes per second. It should be expensive. So let's say you use a SHA hash, which is slightly more cryptographically secure, well, substantially more secure cryptographically. If your table maps user ID, user email into the hash of password, the first thing the attacker would do is take a dictionary of common passwords, hash them all, and if there are matches, then you know, hey, I have no idea what your password is, but for this particular 5 users out of your 1 million users, their password hash matches the hash of hello world. So we know their password is hello world. So to prevent this, you want to use some hash. Oh, you want to use some salt. Salt is just pretty much a string that you prepend or add later, or like add at the beginning or at the end of the password itself before you compute the hash of it. So you never just do hash of password. You do hash of salt as a string plus string concatenation with a password. Now, if it's the same salt for all the users, then you may not be able to retrieve the password. But if 2 users have the same salted password, you would know they have the same password. Again, it's not as insecure, but it's still pretty bad. Like imagine you as a service owner know that of my millions of users, these 5 users have the same password. That's ridiculous, right? You're not supposed to be able to tell that some users have the same password. So the way it's usually dealt with is you have user ID, in this case email, you have their salt, which is a randomly generated string, not too short. And you have the hash of the salt plus password. Yeah, Dorothy, you want to take it from here?
So which direction do you want me to continue?
I was trying to gently steer you towards the idea that in the database, at least they would need three columns: user email, salt per user, and salt password.
So here I shall disagree with you that because also you can use an email as a salt for this thing, and that might be enough.
That's a very good point. All right, let's get back to Julia. I think we kind of hijacked you. So you have a hash function. Let's say we don't do the cryptography part. So our programming language can compute SHA hashes quickly enough. Well, quickly as in easy to implement. We have the database as designed by Dorothy. We may use email as a hash. That's true too. We can use email as a salt. That's good too. Now, how would the transaction to this database look like? Let's say you are creating a new user. What would happen?
So the user type his data, his email to the field, and also he types his password, and it should be typed twice. And then what we do? We take this data and and here I'm not sure where I should do this stuff like add salt before saving into the database. Should I do it always on the server side, and the data from the client to server will be fast? I don't know. It will be like a safe way.
Excellent. What do you think is the right solution?
So definitely, they should be passed in a safe way, but the only reason which I like thinking about, if I do this stuff on the client side, won't it be like too much logic on the client?
Clients are not secure. Full stop.
Well, yes. Let's answer Julia's question first. It is a good point that you usually don't want to overcomplicate your clients.
Mm-hmm.
The general idea that, hey, it might be too much logic on the client side, it's harder to maintain. We changed something there and I had to change all the clients. That's a valid argument. In this particular case, yeah, I'm totally on Victor's side, because you just can never be sure that the line is secure. Even if you know it's SSL HTTPS, you can never know that your operating system is not hijacked. You can never know.
By the way, if it's 96, you have to first design HTTPS and implement secure communication between your server and your client if you really want to protect against man-in-the-middle attacks.
I'm pretty sure Diffie and Hellman wrote that paper in the 80s, so it's not too hard to design it.
No, but you have to implement it.
If we go into asymmetric encryption, it would take us the full 2 hours with no system design outcome. So yeah, let's just all agree that it's in this particular question, theoretically, you could send password as plain text from the client over secure connection. But since you know you need to only match salted, the hashes of salted passwords, you might as well send this salted part from the client, or send this hash part from the client. Now, in order to make it happen, you need the client to know the salt, unless you use emails as salts, as RFA suggested. So let's spend a few minutes talking about the downsides of the idea of using emails as salt.
Maybe it could be like a little bit insecure if email will be like salt.
I think Dima has something to say.
Yeah, how do you change your email? You have to change like all the encryption scheme. Yeah, like ideally we would use maybe some other unique ID for a user or its logging. But I think ID actually, like UUID, some form of it would be probably future-proof.
Well, right. It is not too bad if you use email as salt, and then if you change your email, you just keep this old email as well, salt, in some other column. So it's not too bad. It's not backwards incompatible, but it's ugly. Since if you eventually would need that field, you might as well introduce it right away. So, okay, you want a client to compute this hash of a salted password. It needs to know the salt. So what would the communication between the client and the server look like?
So what if then we like do this transaction, like divide this transaction into 2 inside of 1. The first one will just take user email and or we will just create a user in a database with empty fields, and we only need ID and pass this ID back to the client in order to do this other stuff.
Well, ID as in the salt itself.
Mm-hmm.
If I was hacking your system, I would probably start by creating a bunch of accounts with known salts and polluting your data before stealing it, so that I could then figure out known password computations. Definitely don't do anything on the client.
Well, now you're contradicting yourself. On the one hand, don't do anything on the client. On the other hand, don't send data unencrypted.
Right, so you need an encrypted connection, but over that encrypted connection, you send your plain data.
This would work, but you can still do better.
Can you? With an insecure, completely user-land client? Maybe.
So since we are on this page, I didn't really plan to go here, but it sounds interesting to most of us. So as you correctly pointed out, you would need to reinvent HTTPS if you're in 1998. But the only thing you need from it is this idea of asymmetric encryption. Asymmetric encryption allows two parties to communicate over the insecure line so that only they can read each other's messages. But in this particular case, we do not need them to communicate. We don't need them to read each other's messages in full. We only need one side to transmit something that the other side can match against its own data.
When you're logging in, sure, but when you're setting up your account, you need to pass your plain text password.
That's not true.
Well, or you trust that the client has encrypted it correctly.
Well, I don't think trust is the right word here. The user would not be able to log in if they did something fishy with the password. So again, for those not following, Victor is thinking like an attacker, as should most security specialists do. And he's making a good point. He would examine the communication between the client and the server. If the client does something that is cryptographically insecure, he would know this without even trying to steal your data or trying to reverse engineer the server-side communication. But you can, for example, hash the password twice. You can hash it with one salt on the client and then hash it with another salt before storing it to the database, which is entirely possible.
Mhm.
I really don't want to go into too much detail here. Let's focus.
Right. It means that the client has to send the hash. So if you want to hash with salt on the client, it means that someone should store the hash, the salt. And if the client sends the salt with the hash to server, that's basically the same. So security-wise, it's not much better than just sending a plain password. It's a little bit better in the sense that it probably saves us against dictionary attacks. So if man in the middle, does it?
It does, yeah.
Probably it does. So basically, on the login in the login case, the server gets the sends the hash back to client. No, the salt bound to client, and the client sends back the salt that first salted password. This is possible, but this is not how things have been done in 1990s. Basically, and it's even not something that's how things are usually done now, because people just don't like to have enter login, refresh the page, enter password, refresh the page. It's too much hassle. No one is doing that.
Well, no, wait, that's not entirely true. You don't need to refresh the page. Client-side JavaScript does miracles.
No, we don't have that. They don't have that smart JavaScript in 1990s.
Well, first of all,
do we?
Second, we can do page refreshes seamlessly. The user would not notice.
I guess what it complicates, this approach you're proposing, is it complicates authentication. You need several back and forths to authenticate, whereas if you register with a plain text password and authenticate with a plain text password, it's a single transaction, which simplifies the design.
You're not counting the hidden cost of establishing a secure connection, which is a round trip. Dima?
Yeah, so let's just start from the basics. So to authenticate anything, how does someone proves that someone's identity, that everywhere it's symmetric, asymmetric, the server should be in possession of client secret key, the client should be in possession of the secret key. We're relying on email to edit.
You mean public keys?
What?
You mean public keys?
Sorry, I don't understand.
The server needs to know the client's public key.
No, I mean like secret key in general. Like the server is in the possession of the hash. The client is in the possession of the unhashed password. So that's how it verifies. So we're also relying on the email to be the source of resetting the password. And resetting the password and setting the password are essentially almost the same thing. So for example, so to set the password, what do we need? We need some token that has a limit or unlimited time to live. And so the server is in the possession of this knowledge because it can send it to the email. And then it can also send first some token that allows to reset the password. Then it can set the salt and the encryption scheme. Then a client.
You're making it too complicated. We're not even.
I try to explain it in simpler terms, and probably I'm getting ahead of myself. So yeah, so this scheme should be enough for the client to actually encrypt, hash the password. It gets the salt, the reset token, and the password, and then send the hash to the server. This still is possible to replay attacks if the attacker is listening on the communications. But if we have the time to live for the token, it's less of a threat. So that's it.
In the interest,
if you are going for a multi-step, multi-iteration communication protocol, why don't we just do the standard Diffie-Hellman shared key and then encrypt the password with that key and send it back? And without all of this hashing on the client side, just use
man in the middle can change this token into something else. Okay, so look, guys.
I agree.
In the interest of saving time, let me summarize this part and move on. So the way it's usually done, and the way it can be done safely in 1998 is the following. The server sends the client part of the salt. The client appends its current timestamp, which is supposed to be not too far off the server timestamp. Otherwise, you cannot just register. Appends its own part of the salt, sends this new salt and the salted password to the server. The server confirms the prefix of the salt matches. The timestamp is not too far off to prevent replay attacks, and stores this best salt and the hash of the salted password as the hash to use later. That's the way you can create the user security to prevent man-in-the-middle and replay attacks.
Okay, and now man-in-the-middle knows the salt and the hash password.
Yeah.
And then at login time, what happens in the login time? So man-in-the-middle knows the salt and he knows the hash password. And at login time, server sends back the hash, the salt, as we assume that user cannot store the salt. And man-in-the-middle says, okay, this is the salt I know. And then the user sends, and then it just sends the hash password. That's fine. I see no problem at all.
Well, yeah,
it doesn't prevent anything.
That's a very good point, unfortunately. So it's a much harder problem. You would need 2 more hops. You would need to go back and forth. Yeah. Okay, look, seriously, let's not go into much details here. Let's focus on system design. The next question on my list, which is a lot more system design, is.
I've got a question. Why do we need password at all? If we have a user's email, can we log in them through email and just forget the passwords at all?
Medium did that. Medium's first login system was exactly this. And they advertised it as, it's as if you forgot your password, but you never had your password in the first place. And in 2016, it was a good idea, because ultimately you probably not want to use your email password combo anyways. You would log in through Facebook, Twitter, LinkedIn, GitHub, or whatnot. So yes, but back in 1998, people used to remember passwords. Good times. Let's get to system design. The next important question is, well, look, the operation of creating new users is a lot less frequent than the operation of logging users in. So the database we have is probably a lot more read heavy than write heavy. For every new user created, there are hundreds and thousands of user logins, or maybe hundreds if it's a long lasting session, but still. How do we incorporate this knowledge in our system design so that it doesn't get overloaded quickly and can handle tons of users? On my random list, the next person after Julia, given I think Julia you're a bit too tired, the next person was Anton.
Okay, I was writing down notes from the previous discussion, and could you just quickly repeat what should be done?
So let's say we have the database. That stores passwords and salts and whatnot in some clever format. We established that it's going to be a lot more read heavy than write heavy because clearly people are logging in more frequently than creating new accounts. How do we design a system that it can handle more users without having to scale dramatically?
First, I would think out how many users will log in like simultaneously. That's what we discussed, right?
Good point. How do you approach this?
Okay. Let's say we have like I don't know, millions of users, and so if we have 3 million of users, so it means that if they unifiedly try to log in like in a unified randomization, so it's going to be like 1,000 clients per second, right? If they just do it within an hour. But that kind of seems maybe too much. Because if we have so many people, they usually distribute it widely. But anyway, so it like the quick numbers show that we should work with probably hundreds users per second to be able to log in, right? So what do you think about it?
100 logins per second sounds good.
Okay, and here we need to know characteristics. I honestly don't know whether Postgres can serve it out of the box, or we need to figure out something else. We have some distribution. So here I need to have this number for the database.
Well, so since we're trying to mimic the interview, here's what will happen here. You would have a chat for about 2 minutes during which the interviewer would confirm for themselves you understand what you're talking about. And then we would say, hey, propose a design that can scale horizontally. So let's say you need at least 3 machines and potentially up to 100, and take it from here.
Okay, then we can, in our database scheme, we should have some ID for the user. And the bare minimum of the scheme would be user ID, email, that password, whatever authentication, salt, no salt, and so on. Then we need to have probably some other fields like the phone for recovery or second part of authentication, and some other fields. But anyway, there must be some ID for the user, and we can distribute the authentication based on this ID. Out of the previous meeting,
wait. You're talking database sharding, right?
Yes, we can do it like that. So that's all the IDs starting from, the all ID range within the first 10 goes to one machine, within the second 10 goes to second machine.
This is all good, but let's first discuss what do we need to shard. We have the database and we have the application servers, which would have higher load.
So we have the database and we have the application. So it seems like application would have a higher because authentication happens once, then we just established handshake and then we actually do the job, right? But the topic of our discussion is authentication scheme. So what's
May I suggest some modifications to your design, Anton?
Sure.
So I guess firstly, especially if we're in 1996, you would want to keep your authentication table that contains your user ID, your password, your salt, all of that. You'd want to keep it as thin as possible. So adding phone number and name and address and email to that is probably not what I would do. I would, especially in 1996, make a separate table of users and a separate table of login and associate them.
Well, so look, guys, the interesting part about these conversations is that I feel we understand what we're talking about, but as it always happens, and here's why the sessions are useful, you don't fully know how it looks like from the outside. For example, no one has said something really obvious, which is an expensive hash function. Hashes are super expensive to compute. So by definition, application server would be a lot busier. Databases just store this hash password.
Well, this is true, but not in 1996. Metal is cheap. Mm-hmm. So as long as your application servers are parallelizable.
That's not true. Even in 1998, even if you use MD5, it's still slower. Like 90% of your CPU time of your application server would be used hashing passwords.
But you can just scale your application servers.
Right.
Your database becomes the bottleneck for scaling, and you have to design it in a way that
I'm trying to get to.
Yeah.
Like 100 to 1, well, I don't know, 25 to 1 application servers to databases. Even if you have 1 million users with 100 concurrent logins per second to handle, this can still live on one database, maybe 2 or 3 databases. You don't need to shard them yet, but you do need to shard application servers. So it's a good thing, Anton, you mentioned sharding by user ID. It's important. Just before we discuss this internals, we need to talk system design overall. That's what really is the most interesting part. So how do we break it down? Let's get back to this original question. How do you break it down? What do you scale first, and how do you shard it?
And I'm sorry, what is the application then? So the authentication scheme or something else? Like, do we make it like basically in YouTube, we show the video and we just did authentication and then show the video, or like what? Then what's the application? Maybe I missed this point.
The application of terminology. If I get your question right, terminology. When we're talking system design, there are different building blocks, different boxes that we design a system out of. By far, the most used 2 types of boxes are databases and application servers. Usually, that's a topic for a different conversation, but usually you would say your databases are just simple databases, and your application servers are where business logic happens. We also have load balancers, caches, message queues, middlewares, or whatnot. But usually, when it comes to system design, you're expected to present the argument in terms of, here is my application server logic, here's my database logic, here's how they talk to one another.
Oh, I see.
So, I mean, it really is important, even though we all kind of understand this same way. Let's make sure we use the right phrasing. So what happens on the application server side here is, original user request, hashing, encryption, check-in, and ultimately, if the login succeeds, you issue a token. We'll get to that soon. Database.
Okay,
go ahead.
So essentially, first, okay, so in order to find this user ID, right, first we need to hash a password, right? So essentially, we need to do this application. That's what you're talking about. This application task.
Application as an applying hash function to the password, yes. Application server is more like the process that is running on a machine. A piece of code.
Okay. Okay. So essentially, I'm a user. I'm trying to log into the machine. Machine establishes my identity, and now they have my ID.
The confusion comes from, you're not trying to log into the machine. You're trying to log into the service. Let's say we're building a LiveJournal. You're not trying to SSH into a LiveJournal server. You're trying to log into your LiveJournal account.
Okay. So I'm like going to the web address, right? And then let's say I'm entering my email, and then JavaScript sends it, so the server can predict, or at least kind of predict what it's going to work on, right? So then it can find the appropriate ID and send it to the appropriate application server, which further down the line will be serving.
Okay, what happens next?
What do you think about it? Oh, okay, so then we do this authentication scheme, which we spend like 30 minutes on, and in reality, people spend like years on it. So then the server sends me like that application server sends me the salt. Then I just do something with the salt, send it back, and then server checks like whether the authentication part is equal, and then it needs to find out like essentially it allows me or like sends some status. Okay, this is a correct user, or rejects it.
Okay, so yes, let's take it from here.
Go ahead.
You just described how would the application server look like if all it does is get in the credentials, username, and somehow hash solve the password, and respond back with true or false.
That's a good question, because usually statuses are hard whatever we do, not only authentication. So first of all, we should have like, okay, everything is totally good. And then we need to say like everything is good, but something still happened. Then there is a, I don't know, number of errors from like server error up to, so the server is down to like the password is wrong, or like, I don't know, something else which I cannot figure right immediately.
Look.
So no, it is not true or false. There is some set of status code.
Let's forget about statuses. Let's say we only need to consider two cases. Our hardware never breaks. We just need to make sure we can handle the load. So it's either login correct or login incorrect. If it's incorrect, we could have one of few statuses, such as no such user, wrong password, login expired, or whatnot. Ignore this for now. My point is that there's a lot more logic to be performed by the authentication server, as long as the first phase of password verification is successful.
Mm-hmm.
You could say, hey, you know what? I have two different application servers. I have one set of servers that only checks for password, and the other set of servers that are responsible for actually logging the user in, that issues the access token, that can later use this token to perform different operations or whatnot. And I'm suggesting that you probably want to combine these two into the same application server. So in the real life, your application server, if I'm the user, I'm trying to log into my live journal, and if my password check is successful, what's going to happen is I'm going to receive a token that is my auth token, which is most likely going into my cookies because it's 1998 and there's no mobile app yet. So my browser would have a cookie with my token, which is later passed on with all my requests, and I can use this token to act as myself on this server.
Yes.
Let's talk about this token. Let's talk about what it is. Let's talk about how do we store them, how do we invalidate them, and who actually generates those and how.
Okay, then besides the user scheme, we should have a session scheme, right? So the user logged in, and now it's okay. We know everything's right, and yes, we have the token, and so we have some, I don't know, maybe like default session with some timeout, so user can do something, or user now can do something. If he doesn't do anything within like half an hour, then we log him out automatically.
Who generates the session token, and where is it stored?
So I think that application server, because it verifies that everything's right, then it issues the token based on maybe on a timestamp, or like some other like geographical location, or some other features we're interested in, and then stores this token like in a session table, or like session part of the service.
Well, that's the key part. So we have another database table where the tokens are stored.
Okay. So then in these schemes, it would be, let's say, let's make an ID as well, just in case, because usually ID is useful. Then we have this token. Then we have a time of the login, or like timestamp, where the user logged in. So then the user permission, most likely users are different. It's not like a permission, but maybe the level he has to like do something in the system.
Well, this would all be kind of straightforward from the business logic standpoint. If you need to like let people log in as read only, or maybe log in whether you can or cannot grant permissions to your account to other people, that's simple-ish, as in it is just business logic. Let's talk design. Let's talk, well, first of all, previously we discussed that creating the new user is a heavy operation because it needs to compute a couple hashes and update the database. Now we figured out that the request to confirm login is also pretty heavy. Not because you need to recompute the hash, you can just match that for now. Not going into these details, guys. You can just match the hash for now. But what's more important, you need to create a session token, which is a mutation of the database. Now, what I'm coming to is we have a third operation. Confirm if session token is correct. So again,
wait, we just created it, and we're in the process to returning it to the customer. It is correct.
Let's talk about the API spec. We have the API that we're pretty much designing, right? One API call is create user. We sort of covered that. Another API is log user in. Another API call is log user in. We can forget about delete user and log out. Those are slightly further down the road. The third operation, which is a lot more frequently used, is confirm the user is logged in. I can log into my live journal, and then I'm not doing anything there for 10 minutes. And then I start creating posts, liking comments, replying to them. Every single call like this would begin with the server side of my live journal, confirming I'm authorized to do these operations. Like, could you walk me through how this authorization would actually work? You have an account.
Okay.
What happens next?
So then client should store this token as a key for the current service. And let's say we store it somehow, like use cookie, as you said. So then with all the actions, client sends this token to the server. Server along, so this token now starts working maybe as a password. So because we need to figure out which application server which application service will do the job, right? So we need to know like where to dispatch the user request from the dispatcher. But
dispatcher is a big word. Since you mentioned dispatcher, what would you do in this case?
Everything is a big word. Just one CPU has like billions of transistors. I'm trying to figure out what are the basic blocks what we're talking about.
It's Maxim, your hand is still raised. I think it's from before, right? Yeah, thanks. I'm trying to structure the conversation so that we actually so that you guys can see what goes on in my head as a potential interviewer. And a lot of things you're saying make a lot of sense. The trick is that with the way you guys are answering questions, sometimes it feels like you're jumping ahead of what is obvious to you, but it's not clear what you meant. So everything you said about the schema of this auth tokens table makes perfect sense. But now you say, hey, I have a dispatcher. We should route the request here or there based on something. And I have to immediately ask, what is a dispatcher? Is it a separate module? Is it a separate server? Is it hardware or software? Is it in the cloud? Or just you introduce this term because you know what it means. Can you explain in a few words what it actually does? It really is important.
Okay, so this dispatcher, it's a load balancing agent which distributes their requests to the respective services like Shardit or I mean somehow distributed to do the part of the job.
All right, and then what does it start it based on?
What does it start it?
So you mentioned that it does a sharding.
Yes.
So it knows which shard should the request go to.
Yes.
Based on, I presume, the user ID?
Let's say user ID. So we need to have some key and we can use user ID. And in the beginning, when we thought about hashing, so my idea was that the logging based on the email is being processed and sent to some appropriate application server.
Hmm. Well,
so
yeah.
And we can use the email to distribute the load.
I think this assumption is correct. That's a good assumption to make. But let's discuss how do you actually make it happen. Because if your dispatcher, if your load balancer has to pretty much inspect the contents of the request, it's going to be an expensive machine. You won't just get away with AWS or Google load balancer. You would need to write some software and host it somewhere. So I'm sure you've done it before. I just want to make sure we talk about this in a like another half a level of detail, just to make sure we see the full picture.
No, I haven't done it before. Like, never I wrote a dispatcher or like load balancer, so I'm just widely guessing.
In this case, you were doing extremely well because you wildly guessed pretty much everything the way it's done.
Okay. So let's say I get a user ID or something like that, and I distribute the request based on the range of this user ID. So because I can address the address space of user ID, like the first two letters means like the number of the server to go with. That's how I kind of probably would do it.
That's good. Well, let's get back to validating the auth token. First of all, another one step up. We have the API for the auth server. It can create users, delete users, can confirm logins, confirm logouts, and you need to be able to confirm tokens.
Yes.
Is it the same service that does all five? Would you like to split it somehow?
First of all, I need to find a metric, like whether like one machine can do it or not. Maybe it can, maybe it cannot. As you said, we need to like horizontally scale, so I need to assume that it cannot, right?
Right.
So there is a request from user, whatever this request is, like make some action, or and it goes along with some ID of the user, and probably ID of action. And based on this, I can distribute the load, or I can distribute the request, right? So is this enough, or I need to do something else?
That's good. That's good. Let's go further. So you have multiple. You have some number of databases, and you have some number of application servers, and your load balancer will draw the request based on who it comes from to some application server. We're clear on that. Now, this application server would go to the database.
Yes.
Again, this is something we have not covered yet.
Wait. So wait. So first of all, we have a distributed request. So now we need to make sure that the user is actually authenticated, right? We need to compare token. So we have.
I'm coming back to there. Your sharding scheme for tokens would not be the same as your sharding scheme for logins.
Yes.
So what happens there?
So then the appropriate service, which gets the which actually like works on the request. It's like it has a user ID, it has a token, and it needs to either it already has the database or it should reach some API to make sure that the token is correct.
Well, that is your API. Are you making calls to yourself through your own load balancer?
Wait, we already passed load balancer. So load balancer received the bunch of the data, the email, token, ID of requests, and anything. Then it says, okay, so this request goes to like server 3. So
Right.
now we go to the server 3, right? Server 3 received this like bunch of the bunch of data. So it receives the email, token, like ID of action, and maybe some like data in the form or whatever. So now this server, like this service, needs to figure out whether this request is legit. So essentially, like maybe the token can be like doctorate, right, or something else, and someone like post like as a real Donald Trump. So now we need to authenticate this request with this token.
In order to do it, your application server does what?
And in order to do it, my application, so let's say this application server has the database or the access to database to verify the token is correct.
Right. So what I'm coming to is the following. Let's say you have 100 application servers and 25 databases. Do all application servers talk to all databases?
Wait, 100 application servers?
And 25 databases. I'm making up this numbers as we speak.
Okay.
Do you have a full graph of every single application server potentially talking to every single database?
No, there should be like some range of database because there is no use to talk to all databases. Okay,
let's elaborate on this. If you want to make sure that not all application servers talk to all databases, you need to shard the data in the databases as well.
Yes.
But at the same time, if one application server is down, and if you have 100 machines, sometimes some of them will be down. You don't want the segment of users be gone because clearly the data is there in the database.
Mm-hmm.
So what do you do? Actually, do you feel like going further? Because I think you've answered a lot, and it was a really good conversation. Shall we?
Okay, I believe I know there are other people and they want to talk. Go ahead, just
I'm not
redirect to someone else.
It's more like I want it to be a lively conversation. Thank you. Next on my random list is Victor L.
Okay.
I think you had something to chime in with on dispatchers. That's at least my intuition from, or we can table this and go forward.
In our case, I mean, I would in general like split token verification and from login users. Like token verification is something that we would do much more often once user logged in. So, and yeah, so I would have some database or group of database, doesn't matter, that would just store the tokens, and whatever application need to validate it, it would go to the single place and get it validated. And
so we built in two different services. One responsible for creating those auth tokens, and one responsible for confirming they are correct.
It can be single service. It just talks to different places to create a token and validate the token.
Okay, so can be single set of application servers, but two different databases pretty much.
Yes. Yes.
That's like, before we go further, does anybody experienced in this have a comment?
Well, I was just going to suggest this same change to Anton's design in that you want a read optimized caching style database for your token verification, and you want a write optimized kind of database for your login requests.
If I do this like in 1960, I would just have to like database tables, right? You'll just have your users, whatever, then you'll have your like Victor suggested logins, it's just your user ID, token, whatever, and just verify.
Yeah.
If you can have some cache that will be shared on application levels that will like store up to date your tables of your valid tokens. Something, but I don't know if that is a good idea to go that far. Let's start with just our service token to more dedicated token database.
Yeah, I think 1998 is a bit too far away, guys. I just checked. Memcached was introduced in 2003.
Right.
Then
So-
just the database with
Look, these are very good points. These are two very good points, but don't confuse the two. These are two very good different points. What Victor L said is that you may want to split your databases into read heavy and write heavy. What Victor M says is that the letter, the former is the cache for the letter. They're two different designs. They're both plausible. And let's forget about 1998 because, well, it was just too far away. But seriously, it's important to choose between these two.
And there's nothing that says that you can't replicate your read-heavy stuff into your main database. Like you want sessions, and you want to be able to extend your sessions, and you want to be able to store the fact that your session has been extended so that future requests read that, oh yeah, this session is now valid for another half an hour, and you probably want a log of all of that in some kind of report, but those don't all have to come from the same source. And eventually consistent is probably good enough for session activity being replicated into a database that a report is being generated from.
Well, eventually consistent is the key part here. Does everybody understand why it's important here?
I'd love to hear why.
Well, the shortest explanation, I think it's better if I come up with a simple explanation, which may be wrong, and then you guys correct me because you're so much more experienced, cumulatively at least. The short explanation is that you can win a lot in performance and in cost of your hardware if you can afford to be 100 milliseconds behind. In the case of session tokens, there is really no harm in the logic that, oh, if it doesn't work right away, just retry it after 100 milliseconds. And because you can mitigate this on the client side, on the business logic side, you can afford to use cheaper hardware, you can afford to develop in a different language. It's just a lot easier if you don't have to have a 100% guarantee that your session token's read table is fully synchronized with the session's token write table. I guess I said something right.
No, makes sense.
Yeah, I agree. Transient data is less important and we can care less about that.
So, I mean, if it's 1998 and you have to refresh the page because your login doesn't succeed right away, it's also no big deal. Today, it's going to be done on the client side application, on the client's transport layer. So even the client side developer would not notice that there was a retransmission. But yeah.
Well, there shouldn't necessarily even have to be a retransmission. It should just be it'll take a little bit longer if the session doesn't exist in your cache. You have to go to the database for it and see, oh, does the session actually exist? And if so, replicate it into the cache, and then all of your services will be able to access that session in the future.
But then your session token validation request would be long polling.
No, it would just be a longer request. Your application server would receive the request, not find the session in the cache, and go to the database. Huh?
Oh, if you go to the database at this point, you ruin the purpose.
Well, only if you go to the database more than 5% of the time. 95% of the time hitting the cache and 5% of the time going the long way is still okay.
Well, that's what I meant to say is that you're opening yourself to an attack.
Well, that kind of attack mitigation, there are many strategies to deal with it. Not all of them involve retransmission on the client.
Okay, sure. So everybody on board, right? The token.
Yeah. So I would say that this is just a normal caching, but I don't see why eventually consistent is a thing here in the.
That's a good point. Just caching is even with fully consistent database is giving us 99% of advantage without the disadvantage. So most of the time we just consult the cache and we assume that cache is consistent with the database. When we want to modify the cache of the database, we can do it inside the cache server, whatever it is.
Yeah,
So
whenever we extend a session, we can invalidate the cache. We can even repopulate the cache after we've modified the database in the same call.
Well, I mean, look, Darfay's question is making perfect sense. Why do we even have to be consistent at all here? If the logic is, hey, if we don't find...
No, why? Sorry. So I probably understood it differently. Why we think about eventual consistency when eventual consistency compared to complete full consistency is such a minor advantage. Just having a cache is a huge advantage. So making the database access not so consistent, it's probably another long-hanging fruit, but probably it doesn't give that much advantage than just having a cache. Most of the time, we just hit the cache and we are fine.
Yeah, I think we have to confess that Darfay is right, and we have outsmarted ourselves, because we live in 2020, and we all think in terms of, oh, we have this message queue that replicates one database to the other one, which kind of guarantees that it's going to be eventually consistent. And what Darfay says and what Maxim confirms is that, well, it's good that you do it this way, guys, in 2020. But back in 1999, we couldn't care less. If every 100th request that updates the cache fails for no good reason, it's still a good cache. It just would be 98% efficient, not 99% efficient, which is still a huge win over just going to the database every single time.
Yeah, so the point I'm trying to make is that the default choice in any occasion should be, like in my experience, is that first you try to stay consistent, and you only lose consistency as your last resort because something cannot scale. And something that just cannot scale further. And that's really in many applications a last resort after you're out of, I don't know, one single huge server and with one single function, which you cannot shard anymore or which you cannot do anything about. So usually it makes more sense to stay consistent first and just try to slice off the different functions into different servers. And as your last resort, when your service cannot be sharded and has to have all the data inside, then you lose consistency as a measure. But that's not what you start with.
Well, on the other hand, if you design your whole application to be tolerant of lack of consistency, then it's not a big problem when eventually you are forced to lose it.
No, it's more like first, yeah, I agree here that you try to lose consistency between the different functions. Like you don't need to have transactions that update your users or your teller accounts. You don't have to have them synchronized probably at some point, but there's yeah, you still have to. It's still easier to design a more consistent system that would stay consistent in most parts, but just in the part that you cannot scale would let go of this consistency.
An extremely interesting observation from this conversation is that it is the very same logic which you would apply if you're arguing whether your system should be monolithic or microservice based. You either need to guarantee consistency between the parts, or you let them hang loose, as long as eventually they come up with the correct answer as the whole, as the group. So, I mean, I understand why it was hard to follow. It was really hard to follow how this conversation even emerged from this simple-ish question of doing auth. But the very argument would hold when we're talking about preferred microservices versus a monolithic solution. Just for you guys to keep it in mind in an interview setting. Okay.
I think there's more to that question than I think that's already kind of touching on the organizational aspects of system design and how teams are structured and how they prefer to operate and how deployments are structured and how teams prefer to operate between themselves informs a lot of the kind of microservice versus monolith decision in my view.
Well, there's theory and practice, right? In theory, there's no difference. In practice, there is. So in practice, microservices emerge for reasons that are mostly resembling org structures as opposed to correct decisions. But when it comes to interview questions and top-level architecture, I think it's important to reason about one versus the other based on first principles, which here would be exactly what you guys just discussed. Can you tolerate inconsistency? Is it possible to design the system in a way that just results in inconsistencies over time by itself? Or is it a disaster for you because those inconsistencies will just break the service down the road? Like, it's not a question of if, it's a question of when. All right, look, I had a long list of questions to proceed with this. I don't think we would get to design and login through us. That's just too hard. But I think what we should cover is two-factor. So two-factor is the idea that you have to type in the code from your email, or that is delivered to you by SMS, or you use some authenticator app or authentication token that is a physical device. And in order to be granted an auth token, you need to make sure that the server, the backend of your service must not only validate your password, but also your second factor. How does it change our design? What do we need to extend? What would the new pain points be? If I have to pick one person, the mic is still on Victor L.
Well, we need some other service to validate the second part, right? Like it shouldn't, like the second token shouldn't be decoupled from the first. And if you're talking about phone or
yeah, I think we should talk about phone, to be honest. Talking about RSA tokens that are physical devices are harder.
So basically, we need to introduce another level of authentication for the user with a second token, right? Something that's independent from what we did before, and something that's unique for the user. And as a part of something that he won't use too often, the two-step part. And whenever we authenticate it, yeah, it should be independent, like really from what we're doing already with our regular login password.
Would it be a separate service, or would you extend the current service?
I mean, application level doesn't matter. It can be your still same application doing the verification with your Auth token, but the token itself, I mean, it depends. Like if you're doing some whatever, like real life tying to the identity or something else, and you need to like queue some other third-party service or API to get that yes or no for the user, yeah, you talk to them. If you're doing something within your company, like on the phone, and you're just storing the extra piece somewhere, again, can be same application, different database. I mean, so it's like, okay, it again depends. Either we're doing like microservices or a single monolith, but it still has to be part of your authentication, well, module in general. Just extension.
Dima, you had your hand raised for a while.
Yeah, just so let's make sure that everyone is on board with second factor. So just quick, like why second factor is even important. So it's just second factor is usually some separate device from your computer. So if someone gets access to your system and you have a second factor, then it's way harder to hack someone or get into someone's account. So separation is mainly for the client, on the client side, not usually on the server side. Yeah.
That's important, yes. Well, on the client side, I think Victor started touching on this. Technically, on the client side, the floor expands too. The flow of actions you have to take to log yourself in now has at least one or more like 2 extra steps.
That involve other services that already kind of tied to you with a different type of, well, kind of not authentication, but like you still need to either use a personal phone, right, or Gmail or whatever, or physical device. Yeah.
Well, okay, let's talk about the design of our system. Let's say it's an SMS-based second factor. What happens is the user types in the username password, and they move to the screen where they have to type in the code that was just texted to their phone. We have some service on the backend. Let's not worry about which service is that, which can guarantee that this text message will be delivered. What happens on our side, on the database level, on the state machine level, in order to make this happen? What do we need to change? What do we need to extend in our design so far for this logic to be possible?
No, it's your token. I mean, you kind of, your token extension, creating another temporary token for one that you just emailed, like that will be, well, your SMS that will be valid for some time for user to enter, and then we expires it eventually. So
what I'm trying to ask is, so we talked about these 2 different databases, or maybe a database and a cache for it, to separate read heavy and write heavy and read heavy. Now, if you don't have second factor, your login request just ends up creating this valid auth token in the valid auth tokens table pretty much. If you have second factor, you cannot just create this record in the database because the token is, you cannot issue a token yet. So you have this tri-state, you have this limbo state where the user, well, first of all, simple first question. Do you even send the user a text message if they have typed their password incorrectly? Or is it strictly one after another?
no, first you enter correct password.
Why not?
Maxim?
Why not? So why should we help the attacker to know that the password is correct or incorrect? So we just send the secondary authentication token all the time.
Well, maybe we don't want to help the attacker deny our, attack our service by repeatedly sending text messages while entering incorrect passwords, attempting a credential stuffing attack. Assuming we have to pay for text messages, which we probably do, we probably want to use them sparingly.
If you already know your password and he's trying to hijack you, I mean, that's a bit rather. Don't end it before you
This is actually a real problem that a lot of companies have had with attackers just making them send a text message, which is a pretty expensive operation. So you end up with a lot of timeouts and things that affect real users. So probably better to wait.
All good points. There's one more important point to be made, which is the end users tend to get suspicious if they get those text messages. You don't want users to be frustrated because, I would say some 1% of users would be tempted to be scammed at least once. I would lose trust in the service if suddenly it tells me that someone is trying to log into my account. I would assume the service can handle that on its own. All right, but I think from the maximum security prison standpoint, Maxim is right. We should never ever tell the user, we should not discriminate by this password matching. But at the same time, this argument can be stretched further. You also do not want to even tell the attacker if this account exists at all. So ideally, when a bad guy is trying to guess password, they would not be able to tell from the way the system responds if this account even exists. It may never have existed or been disabled just yesterday, and the attacker would not be able to see that.
So it looks like we can ask for the second factor in any case, but it doesn't mean that we have to send the SMS in if the password is correct.
Well, that's not a very user-friendly flow. If you enter the incorrect credentials and your user is prompted for a second factor, and then only after successfully completing this, or rather never receiving his SMS because his password was incorrect and not being told about this, he's going to be one very angry user and you'll probably never see him again.
Yeah, what Darth is talking about is like calling double bluff. If the attacker wants to spend our money by making sure we send lots of text messages, we can pretend to send them.
Well, first we have to know he's an attacker, not an angry, frustrated real user.
Yeah, we can only do it for the accounts that were disabled.
Yeah.
Or for accounts that don't exist.
Okay, with this being said, let's say we settle with the decision that we only send a text message after the password has been confirmed. So now we have this tri-state, when on the one hand we cannot yet issue the auth token because the user may well not type in their second factor. On the other hand, we have progressed way beyond just typing the password. We know the password is correct. How do we make sure this plays well with our database structure and with our dispatcher/load balancer and with our caches?
Create a partial record in your sessions database.
Well,
When you
some tokens, right? Like you have your.
Yeah, the other option is to just create a token but not issue it yet.
And keep it in cache until you
But
get.
that's ideally the 2FA fact would be included in the token. So probably you wouldn't want to issue a token or create a token even in your system until we know that it's a legitimate login request. So I'd probably err on the side of just creating a partial record that would indicate an incomplete login attempt, and I would probably persist it somewhere in case between entering a password and entering a second factor, whichever server was handling that request went down and a different instance had to pick up that transaction.
Okay, nobody mentioned one important thing, and perfect.
So one thing I want to raise, I don't know if it's the same thing that you have in mind, is that what I've seen in banking systems is the second factor is actually protecting just some operations and not all of them. So you actually log in with your password as normal, but you cannot do anything until you enter your second factor. And that could be just similar design to our first login, just as you check the first login and then do the second session for a second factor.
It would essentially be a new token that would be issued in that case, right?
Or you can upgrade permissions on the old token. I think you're talking about the same thing, more or less. So, I mean, you can say that I could make an argument that what you said, Victor, is the weak version of what Darafay said. Is that once your password matches, you have a partial token, which gives the user zero permissions, except being able to get to the second screen of typing in their second factor authentication.
There's also a third option, which is we do nothing and we force the client to retransmit the password along with his second factor, and then we can check the whole thing at once.
All right. The thing I wanted to mention that no one did so far is client-side tokens. Is anyone familiar with this? I think, yeah, I was actually hoping, Dima, you would speak up.
So yeah, I just wanted, that's a bit sophisticated topic for 19. So yeah, we can actually use asymmetric cryptography to issue tokens that aren't stored in some kind of transient database that is read optimized or some kind of memcached. So yeah.
Hold this thought. You said too much already. This needs to be.
Okay, sorry. So yeah, one way is to actually create a client-side token, to issue a client-side token that is stored locally by client, and it's signed by the server secret key. And usually it also has some time limit to it. If you ever heard of It's Dangerous Python library, then it's probably the most known one.
So the idea Dima is talking about is that we never ever have to store tokens. We just make sure the user stores tokens. We don't need a table for them because the mathematics, the machinery we have to validate those tokens can just decrypt the token. That's why we don't need hashing, we need encryption, because we need a reverse operation. We encrypt the token, get the client, let the client store it. Once we get the token back from the client, we decrypt it. And then we can, well, I mean, honestly, there's a continuum. You can have a client, you can have a token 100% client side, so you store nothing. You just decrypt the token and use it. It would most certainly have a time limit on that. Or you can have some partial data that you still need to go to a database. You don't store the full token, but you only check something simple. So is everyone following here?
Even the decryptions get expensive after a while if you have a lot of users. If you have like many different services and all of them have to decrypt the token for each call, that becomes more expensive than just checking a cache.
Well, I was actually trying to play a trick on you guys and ask how can you combine these two ideas? Client-side token and upgrading the token after two-factor is received.
Well, you would reissue the token, or rather you would store permissions separately from the token in your system, and then you would change the permissions after two-factor. You can do either way, I guess.
Well, on the server side, you know exactly what the second authentication password code should be. So you can create the token, which becomes valid once you have the correct code.
Mm-hmm.
You can handle this at creation time.
Mm-hmm.
So you don't need to go to the database. It's just if you do the magic with this token that you have issued, you do the magic on the client with this token plus the code you have.
Second factor code, yeah.
The token either becomes valid already with no more rights to the database, read-only access through the cache, or it just doesn't work.
Mm-hmm.
Sneaky, huh?
Yeah, well, we should still think about like these schemes are a bit vulnerable to expiring sessions. While if we store it server side, we can quickly expire all the sessions by just deleting them. But like something that is valid for a week can do quite a lot of damage. So then we can mitigate it by implementing a separate database that holds compromised tokens.
Oh, there's one more trick, by the way. If your tokens are issued for a small period of times, for shorter periods of times, you can design your API schema so that once you make a call with a valid token, the new token comes back. So as long as you do something every 8 hours or so, you haven't ever go in session. But once you do nothing for 8 hours, you have to relog in. That's another standard-ish trick. Right. Well, I think we covered a lot. Darthey?
I just have a thought that I want to explore. So after mentioning the second factor is just like the first factor, I thought that it also enters interestingly the realm of forgot password mode. So basically the forgot password is logging in just with the second factor without the first one. If you have any ideas about this or think that we should discuss it, or Dima, you're the moderator.
I think we should discuss it.
Yeah, so I don't know if I've stated my idea clearly enough. It is that in principle, if you just track if you make a separate way to log in by different means, one of them being a password on login and the other one being an SMS token, then you can, in principle, log in, and the third one being the email access. Then in principle, if you require just two factors, you can say that I don't want to enter a password on this machine. I just want to have my token through email and through SMS, and that would be a two-factor entry to the system. Even though you don't share your token, your password, you don't type it in a keyboard. That's one thing. And the other thing is that forget password can be just an operation that would require one single token, or change password. And this way you can get it through your SMS or another means.
So the former question you asked is actually fairly popular in the world of cryptocurrency, because oftentimes the way it's stored in a semi-centralized way is the service guarantees that there are 3 keys, one kept by you and two kept by two halves of the system, so that in theory they can recover it. In practice, they never would, because there are secure mechanisms internally. So this is often used. In practice, back to your first point, the way it is usually done is the way WhatsApp logins on the third-party device. So they would show a barcode which was came with your phone that is logged into your WhatsApp, and this computer, this browser, becomes the thin client to your WhatsApp account. So you don't. So I mean, look, you're trying to solve the product problem. You're trying to make sure that you can use your service without typing in your password. And you're trying to be sneaky by saying, you know what, instead of my password, I would much rather type 2 codes, one to my phone and one to my email, which means you have some device that has access to your email. And I'm saying that it's a lot better if this device that has access to your email can communicate with this insecure computer. The easiest way being to scan a QR code, one way or the other. So the way WhatsApp does it is, hey, here's the barcode on the shared computer. Scan it with your phone, and we'll give you a temporary WhatsApp session. You can do the opposite. You can say, hey, this is the public kiosk with a webcam. Open this QR code on your phone, show it here, and you can use this. That's a product solution that kind of invalidates your idea, even though your idea is useful.
Yeah, I think the kind of general rephrasing, if I'm not mistaken, is that our services should be designed in a way that they're kind of agnostic to which secret mechanism is being used. Like if you want to enable some users to just log in on their phones, or just use their password, or some have to use both, or whichever, it shouldn't matter.
I think your second idea, Dorothy, actually warrants a conversation. So could you phrase it again so that we can start?
As I don't quite understand the difference between the first idea and the second idea that I stated, could you please clarify what's the difference that you see?
Okay, disregard it. They will be tricky now. All right. I think it was good. I think we covered a lot. Anything we should go through before we wrap this part up? Any questions, last words, suggestions?
So yes, like you can probably provide some resources for people who are more interested in this, like something on the top of from the top of your head.
Well, honestly, I've never done anything like this before in terms of authentication as an interview question. The reason we're doing this is for a previous session where we discussed geospatial Yelp design. I got some feedback from people I trust that it's a pretty low-level problem that is not too system designy. So I was hoping that designing Auth, which we did today, was a topic which would open up a lot of conversations about how server A talks to server B, how the load balancer comes into play, how do you shard the database into the leader and the cache. And I think this goal was achieved. But it's still not truly a system design problem. So I don't really know off the top of my head what can be a good resource to go on this.
So I'd say that educating oneself on the TLS and PKIs would be a good, you'll spend your time really worse it will be worth your time spending time on TLS and PKIs and how TLS actually works in browsers, and mutual TLS authentication on the continuation of this topic, and actually maybe learning about LDAP and Active Directory as a enterprisey way, more enterprisey way to handle authentication. And yeah, there are more topics on that, like, yeah, read about OAuth2 that was designed by Google and more company as an example of protocol that was designed by a committee and is quite complicated, I'd say.
Yeah, good summary. I would also add that even if you're not doing any cryptography in your life, you should really know what public and private keys are. And you should really be able to tell symmetric from asymmetric encryption. Know what man-in-the-middle attacks are, because they are always painful to defend against. And this simple idea that if you have a centralized authority that can validate your key, in the case of HTTPS, it's the, well, what's it called? Certificate holders, central certificate holders, certificate authorities. So once you have this authority, you can design a system quite easily. That's what HTTPS does. If you don't have it, well, you end up with Bitcoin, which is a lot more impactful to the world's temperature so far. I mean, you need a lot more time and a lot more CPU cycles burned to maintain this system. So,
yeah, and another thing I want to add as a closing thing, there's a thing called JWT, which is a way of building a token. And one thing that you may want to try at home is to log into your favorite services, open up your browser tabs to find a session key in your local storage, and try to put this session key into your JWT decoder. And oftentimes you will figure out some interesting info that that would actually be a JWT token, and you will find out what server is trying to store about you. Sometimes it has permissions, sometimes it has your login name, sometimes you have some other fancy things.
Yep. All right. Thanks, everyone. Shall we wrap this up? I think we should. Thank you. Take care.